This is my video lab report for Lab 5. I chose to model friction. My system was a box moving across a carpet, and the purpose of this lab is to determine the coefficient of friction for the system and to correctly model the motion in the Python. The primary principle used is Newton's second law to create the model, and the main results of the lab was that the kinetic coefficient of friction is 0.25, and the model does successfully reflect the data observed to an acceptable margin. First, I want to talk about kinetic friction. So your friction force is calculated by multiplying your kinetic coefficient of friction by your normal force, and the normal force is merely mass times gravity. So in this case, the mass of the box is 0.681 kilograms times 9.8 meters per second squared, and you get 6.674 newtons as your normal force. Because I do not know the coefficient of friction, I manipulated that in my model to a point at which it most closely correlated with the observed data from Tracker. Speaking of which, here is the data from Tracker. You can see here the movement of the box across the carpet. It decelerates rather quickly and comes to a complete stop. For this system and model, your F net is essentially just the friction force, because there's no force of the hand after the box leaves the hand. It just merely has an initial velocity. And your static force of friction, F sub s, is 0 while the box is in motion, but that force is what keeps the box at rest once it decelerates to 0 meters per second. Here we see how Newton's second law applies to the system. The top two equations are what are in BPython. Those are what actually model and progress the system throughout the loop to create the plotted model at the end. The time step for the model is half of what is used in the observed frame rate, just to get a better accurate picture of what we're modeling. Here we have the results of the lab. You can see the calculated coefficient of friction on top is 0.25, and here we have the two graphs plotted next to each other, the observed in the model, the observed in blue with the model in red, and you can see that they are rather closely correlated. They overlap at the beginning and the end with only a slight variation in the middle. That variation was originally larger, but was shrinking down by manipulating the different coefficients of friction, both kinetic and static, to get it to where it is a much better fit. In conclusion, the objectives of this lab were both fulfilled in that the coefficient of friction was found to be a finite value, and the model closely fits with the observed data. So thanks for watching all these videos throughout the semester.